All right, so this one's a little different, obviously, than the ones we were doing yesterday because we're looking for the angle instead of being given it like we usually are. So we have this ball thrown into the air, okay, and it's thrown at 35 meters per second at an unknown angle, right? And we know that it's in the air for 2.5 seconds. So they actually give us the time here. That was something we had to find in every question that we've done up until this point. So that's a pretty useful piece of information, given that it fits in both the vertical and horizontal parts of the question. Okay. It also tells us that it's going to land 70 meters horizontally from the point it was thrown. So they told us the horizontal distance. Okay, what can I find right now with D and T horizontal? I can find the velocity horizontal, which we learned yesterday is this side of that original triangle. And we just finished saying that if we have two sides, we can find the angle. So that's probably my best bet, is just to figure out what V horizontal will be by going 70 over 2.5. Okay, what's 70 over 2? What is it?
28.
28, right. Okay, so we got 28 meters per second, okay, for now this side of the triangle. So now we've got the adjacent side, and we've got the hypotenuse. So if I go theta equals cos to the -1, or inverse cos of the 28 over the hypotenuse, 35, I should be able to get my angle that I was looking for. So inverse cos of 28 divided by 35. All right, so we're looking at a 37-degree angle on this. All right, so in the end, that's, even though like wording wise that question looks like it should be tricky, there's very little to do there. Okay? Like way less than what we were doing yesterday when we were finding the distance and finding the maximum height and all that kind of stuff. Okay? Sometimes you're going to run into projectile motion questions that are actually worded so they seem difficult, but mathematically are very fast, very quick kind of questions. Okay? Anybody need that one anymore? Okay, this one is tricky. Definitely tricky. You really have to understand what's going on here, and you have to understand that in this motion, the starting height and the ending height are the same. Okay, so it lands, it's launched and lands from the same altitude. Okay? Think about what that means for some of your vertical information, because it's a bit of an algebra trick to solve this question. All right, so for this one, we don't know the angle. We don't know the projected velocity. All we know is that it travels horizontally 30 meters in 10 seconds. Okay, from our vertical perspective, okay, we know that the time is 10 seconds, and we know the acceleration is negative 9.81 meters per second squared. That's all we know. They want to know the projected velocity, so they want to know that number and the angle. And I'm supposed to get that from 30 seconds, or 30 meters and 10 seconds. All right, well, the 30 meters and the 10 seconds can help me with at least part of this. It can get me this side of the triangle. Okay? That's useful. I'm going to need that if I want to get the hypotenuse and the angle. I'm going to need two sides. And the only sides I have any hope of getting are the horizontal side and VI. Okay? So I'm going to get the horizontal side right now. Okay, by just doing that simple V equals D over T calculation. Okay, 30 over 10, this side is 3.0 meters per second. Everybody all right with that? Okay, how do we get VI?
This is just how I did it, but I basically knew that negative 9.81 would be equal to essentially negative x minus x over 10. So then I times negative 9.81 times by 10, and then I divided it by negative 2.
What she said. Okay, so that went like this, don't worry. Okay, so here's what she's saying. We know that we have this acceleration formula, and on every single projectile motion problem we've done, we've used that to get time, which we could do because we knew what VF and VI were. They were always the same, right? If something goes up and comes back down, VF and VI are the same, but opposite in direction. Okay, so really, what we're saying here, instead of VF minus VI, I'm really saying this. A equals negative V minus V over T. They're the same number, but one of them's negative. Does that just make my algebra a little bit easier? Because now instead of having two unknowns, I only have one. That's the understanding part that has to happen in order to solve this problem, is I have to understand that VF and VI are equal in magnitude, but opposite in direction. In other words, they're the same number. Okay? If I remember that, then I can get to this point here where I'm eliminating one unknown by essentially, or two unknowns by essentially making them the same unknown value. All right, so now, if I'm manipulating, I've got A equals negative 2V over T. Right, because negative V minus V would be negative 2V. Agreed? Looking at me like I'm, did I lose you? No, okay. All right, so I've got V here. I need to solve for that. So I'm going to multiply both sides by T, and then I'm going to divide both sides by negative 2. That'll leave me with V, which is VI, which is what I'm looking for the other side of that triangle. Okay, so all I have to do is plug in my numbers. That'll be 10 seconds times negative 9.81 over 2. Okay, so I've got negative 98.1, sorry, over negative 2, divided by negative 2. So VI is 49.05 meters per second. So when they threw this thing in the air, they threw it almost straight up. Okay, I mean 3 meters per second horizontally and almost 50 up. Okay, that's pretty much straight up. Okay, and someone was really just kind of doing this and it landed just over there. Okay, didn't go very far. All right, I mean it was 30 meters, but for gosh sakes, they threw it at 50 meters per second. I don't know who can, not even a major league pitcher can throw that fast. Okay, so, all right, so we've got that information. Now that we have this number, we can go back to our diagram. And now we can get our hypotenuse just using trigonometry. So this will be what we call our projective velocity, okay, or V. So that'll be just a Pythagorean theorem. So we'll have 49.05 squared plus 3 squared. All right, so 49.1, and it's essentially still just 49 because I think we only have two significant figures here. Okay. 49 meters per second. Now I need to find theta. Okay, theta is going to be tan to the minus 1 of the opposite side, 49.05, over the adjacent side, 3. Okay, so this is going to be a pretty big angle. All right, 87 degrees. Yeah, so pretty much straight up. Okay, they threw it at 49 meters per second at 87 degrees above the horizontal. Okay, so that'll be our final answer. 49 meters per second at 87 degrees above horizontal. Okay, so that one had a bit of math, okay, and a bit of that checking your understanding, making sure you really get the fundamentals of projectile motion. Okay? Understanding that whole VF and VI are equal over the course of the whole trip idea. All right, anybody need that one anymore? Okay, so now this side's V horizontal, and this side is VI. So now VI is actually going to start out positive or negative? Negative. Okay, now in this case, will VF and VI be equal? No, they won't. Okay, we're not talking about landing at the same height we're being launched from. We're being launched from here, we're ending up down there. This is a lot more like a horizontal one, except it actually is being thrown downwards a little bit. Okay, so this is your 30-degree angle. Okay, essentially what you have here is an arc that's going to look like that. Okay, even steeper than one that would go off horizontally. Okay, because it's going to have an initial vertical velocity not being 0. All right. So I'm going to give you a few minutes to try that one, see how you do, and then we'll walk through it together. Okay, so as we were saying, the difference with this one is just that our arc is going to be kind of flipped, okay, or rather our triangle is flipped. Our arc is going to change quite a bit. Okay, but we still want to split this up into vertical and horizontal parts. Okay, so we'll have the vertical parts over here. Okay, VI is still going to be the sine of 30, okay, times that 12 meters per second. Okay, so times 12, so VI is going to be negative 6 meters per second. Okay, because it's down. Right, our acceleration is still going to be negative 9.81 meters per second squared, okay? And we're looking for how high above the ground the incline is. Okay, so basically we're looking for the vertical displacement of the ball.
Sorry, wouldn't it be 12 times 10 because is the arrow not the hypotenuse in this case?
No, the 12 is the hypotenuse. I'm looking for VI, so it's the sine of 30. Yeah? Okay. And then horizontally speaking, okay, I know that it's going to land 1.4 meters from the base of the incline, so that's my horizontal distance traveled. Okay, and I can also find my V horizontal because I've got that triangle. Right, so I'm going to have the cos of 30, okay, times 12, so that'll be 10.4. Okay, so I want to find the vertical distance. I need one more piece of information. I either need VF or I need T. Can I get either one of them? T. Yeah, I can get T from the horizontal information. Okay, and this is stuff that we've done before, right? If I can find time, I can use it on both sides. I can use it to find the other thing that I'm looking for. Right, so I'm going to find the time here. T equals D over V. Okay, so that'll be 1.4 divided by 10.4. Okay, so it's not going to be very long. It's going to be a very short period of time. Okay, so 1.4 divided by our answer there from the last question. Okay, so it's only falling for 0.13 seconds. So not very long. This is not a very high table. Okay, so now that we have the time, 0.13 seconds, we can bring it over here. And we can solve for D, and we can use this formula. Because I know acceleration, I just calculated time, and I know what VI is. Okay, so I can go D equals negative 6 times 0.13 plus 1/2 times negative 9.81 times 0.13 squared. And obviously I'll use all the decimals when I do that calculation. Okay, so negative 6 times, oh shoot, that number, okay. Plus 0.5 times negative 9.81. I could have actually not bothered with the negatives if I made everything positive on this one. Times that number squared. All right, so the height of the table is 0.89 meters. I got a negative number because I calculated the displacement of the ball, which is down 0.89 meters. And actually, it would be 0.90 meters because I have only two significant figures. Okay, that would be the height of the table. So it's still the same set of steps, but obviously this question had a slightly different setup than the other projectile motion problems that we've done, and that's something you do have to watch out for. All right, so in your digital workbook are some projectile motion problems that I want you guys to work on today and see how we do. I will put them up on the board here. Okay, so there are our projectile motion problems. Some of them are going to be horizontal ones. Okay, we haven't done one of those in a couple of days, so Dave might be a little rusty on those, but the first few are projected horizontally type questions, so you can give those a try, and we'll go through any ones that give us trouble. Yeah. Okay, so for number one, okay, we've got, whoa, that was weird. For number one, we've got an object thrown horizontally, okay, 10 meters per second from the top of a 90-meter building. All right, so vertically speaking, I already know that the distance it's going to travel is 90 meters. Okay, I know that vertically its acceleration will be actually I don't even need to make it negative, 9.81 meters per second squared. And since it's thrown horizontally, what's VI? 0. That's what I have to remember about an object being thrown horizontally. If I forget that, it's pretty hard to get started on a question like this. Okay, from a horizontal perspective, okay, I know that the speed is 10 meters per second. Okay, we would need to calculate the distance from the base of the building. So it's going to do this. I'm looking for the horizontal distance it travels. Okay, what can I get right now with my vertical information that might help me? Time. Yep. Okay, I have to get time from my vertical information. D equals VI times T plus 1/2 AT squared. Since VI is 0, D just equals 1/2 AT squared, and I'm solving for T. Okay, with that formula there. Okay, that's just it manipulated. All right, so we got 90 meters is our distance vertically, divided by 1/2 times 9.81. That'll give us our time. So, 90, square root of 90. 90 divided by divided by 4.
It's not under the square.
Ah, now it is. Okay. No, it's not. Screw it. We'll just try it this way. We'll just do it again. All right. 90 divided by 4.905. I don't know what's going on here. Okay. So it's falling for 4.3 seconds. Okay. Okay, now that I know that, now I can bring that over here as part of my horizontal information. And now I can find the distance, V times T, okay? So it'll be 49 meters. I think we only have 2 significant digits here, right? Sorry, did I calculate that wrong? Oh, because I just wrote it wrong. It's 4.3, not 4.93. Okay, 4.3 seconds. Okay, and so when we multiply all of that together, we're going to have our 4.28 whatever times 10. Okay, so we get 42.8. 42.8 meters as our horizontal distance. Okay, any other ones giving us trouble? Don't be shy about asking, guys. Okay, keep going.